Okay, so today's topic is Schrödinger's wave equation. One of the topic that is very important in terms of JEE and अभी जो नीट का लेवल अप हुआ है तो उसकी वजह से हमें भी श्रोडिंगर वेव इक्वेशन को थोड़ा डिटेल्स में ही स्टडी करना चाहिए जिस वे में जेई के स्टूडेंट स्टडी करते हैं. तो श्रोडिंगर वेव इक्वेशन इज नथिंग बट इट इज द मैथमेटिकल फॉर्म ऑफ वेव मैकेनिकल मॉडल. वेव मैकेनिकल मॉडल में हम जो भी चीजें सीखते हैं वो सारा चीज जो है वो एक मैथमेटिकल फॉर्म के ऊपर डिपेंडेंट है. एट दैट मैथमेटिकल फॉर्म इज श्रोडिंगर वेव इक्वेशन. श्रोडिंगर वेव इक्वेशन आप किसी भी किताब में या एनसीईआरटी में अगर देखोगे तो यू विल सी इन ईदर ऑफ द टू equation form. One is Hamilton operator form and other one is on the form of del. The Hamilton operator psi is equal to E into psi, that is the Hamilton equation, and del equation is del square psi plus 8 pi square m divided by h square E minus v into psi is equal to 0, where psi is your wave function. See, the equation that is given to you, you just need to remember it because no questions will be asked on solving the equation. You just need to know that this is the equation that is being used in order to find out the quantum numbers, that is principal quantum number, azimuthal quantum number and magnetic quantum number. And as electron has got a wave function or wave nature, so that wave nature will be represented with psi with the suffix of n, l and m, where n is your principal quantum number, l is the azimuthal quantum number and m is your magnetic quantum number. This psi has got two parts. One is radial part and another one is angular part. Radial part can be expressed with the help of principal quantum number and azimuthal quantum number, whereas angular part can be expressed with the help of azimuthal quantum number and magnetic quantum number. This is the general form of our equation. There are a few equations that can be seen on the screen. You don't need to remember all those equations. I have just written those equations in order to explain that suppose there is a principal quantum number of 1, azimuthal quantum number as 0 and m is as 0. It actually represents 1s orbital, and this 1s orbital is represented with a wave function that is expressed over here. If I talk about 2s, 2s is expressed with this expression that is written over here. Next one, n is 1, n is 2, l is 1, so it is representing 2p orbital. 2pz. Why 2pz? Because magnetic quantum number is 0 over here. So every orbital that is being given to us can be represented with the help of Schrödinger's wave equation. But why we are studying the Schrödinger wave equation? That is very important. Because with the help of Schrödinger wave equation, we can draw the graphs of different orbitals such as the graph between psi r versus r, psi square r versus r, 4 pi r square, psi square r versus r. I will explain each and every curve one by one, that what these curves are represented and how these curves should be drawn. Whatever graph you are drawing, the first thing that is very important to draw these graphs are to calculate radial node for a particular orbital. And radial node is calculated with the formula of n minus l minus 1. The graph psi r versus r represents wave function. Psi square r versus r represents probability of finding electron at a distance of r 4 pi r square psi square r versus r represents probability of finding electron at a volume element from a distance of r. And this distance of r is basically from the nucleus. The distance is basically calculated from the nucleus. All these three graphs actually represents this. And we will see how with the help of radial node I can draw all the curves. Before getting into drawing the curves, we need to understand one thing over here, that is RPDF, radial probability distribution function. What is radial probability distribution function? Let us understand that part first and then we will get into the graph. As I was saying that the graph of RPDF, it actually measures the probability of finding electron in a spherical shell between thickness r plus dr and r from the nucleus. R and r plus dr from the nucleus means there will be a volume element which is at a distance of r from the nucleus, and the volume element will be calculated between r and r plus dr. Now, in order to calculate this volume element, what I will have to do? I will have to subtract the smaller sphere from the larger sphere. That is what we are doing over here. That the volume of the radial shell is equal to dV, which is 4/3 pi r plus dr whole cube minus 4/3 pi r cube. If I expand r plus dr whole cube, it will become r cube plus 3r square dr plus 3r dr square plus dr cube. Now, dr itself is tending towards 0. That means dr square and dr cube will be almost negligible. So we are neglecting this two part. After neglecting, what is remaining? If I take 4 by 3 pi common, r cube plus 3r square dr minus r cube. So r cube is getting cancelled out. So dv is becoming 4 pi r square into. Now this is your volume element which is present at a distance of r from the nucleus. Now in this volume element, the probability of finding electron is represented with chi square r, which is equal to P divided by dm. So P will be equal to chi square r into dv. This P is nothing but probability of finding electron in this volume element. That is what we found out over here. P is equal to chi square r into dv. Now if I put the value of dv over here, it will become P is equal to chi square r 4 pi r square into dr. Now this P is the probability of finding electron in this volume element. If I divide P with dr, I will actually get RPTF, radial probability distribution function. So it was chi square r into 4 pi r square into dr divided by dr. So RPDF is equal to chi square r into 4 pi r square. So this is nothing but radial probability distribution. Now our task of drawing the graph will start. Whenever a orbital is given to you, suppose 5s is given to you, the first thing that you need to do is to calculate the radial route. The value of n is 5 over here, value of n is 0 over here, n minus l minus 1, that is equal to 4. What radial node represent? It represents number of times graph will touch x-axis. Basically, radial node represents a point where probability where there is no probability of finding electron. That's why whenever there will be no probability of finding electron, the graph should touch x-axis. Suppose for 5s we got radial need as 4, so the graph for psi r and r will look somewhat like this. See, it is touching x-axis how many times? 4 times. If I want to draw the graph of chi square r and r, it will also draw in such a way that it touches the x-axis 4 times. I will explain you. If I draw the graph between R and RPDF, it will also touch the x-axis 4 times. So radial node is basically representing that all the graphs should touch how many times? The x-axis. Now, if you observe, when we were drawing the wave function, at that time you had a positive quadrant, you had a negative quadrant. You had a positive quadrant, you had a negative quadrant. In wave function it is possible. But if I am drawing chi square r, then it is a square, then it will never have a negative axis. It will only have the positive axis. And with distance, as r is increasing, you can see that the probability of finding electron is decreasing. Obviously, if I go away from the nucleus, my probability of finding electron will decrease. That's why the peak is coming down. But in case of RPDF, you can see that as R is increasing, the peak is also increasing. Isn't it? You can see that the peak is also increasing. Oh, there's a slight change over here, sorry. The peak is also increasing. Why it is happening? Because RPDF is 4 pi r square, chi square r. At this point, the value of r is what? 0. If the value of r is 0, then RPDF should also be what? 0. If you take a graph and if you want to draw the graph of r square with respect to r, you know that with time it is increasing. But if I want to draw the graph of chi square r, you can see with r, your chi square r is what? Decreasing. It is increasing and it is decreasing. As we go away from the nucleus, the value of R is increasing, so the value of R square is also increasing. If the value of R square is also increasing, then it will also increase as R square is dominating in nature. There is a multiplying factor. अब एक कम हो रहा है, एक बढ़ रहा है, लेकिन जो बढ़ रहा है वो डोमिनेटिंग है. अगर वो डोमिनेटिंग है तो ओवरऑल वैल्यू भी क्या करेगा, इंक्रीज करेगा. सो द ग्राफ इज इंक्रीजिंग. So this is a mathematical explanation. Okay, this is a mathematical explanation. But if I want to explain it theoretically, you can think in this way, that around nucleus you have got s orbital, then you have got p orbital, then you have got d orbital, and then you have got f orbital. Suppose you are going away from the nucleus and you are taking a volume element. Then in that volume element, you have the probability of finding s electron, you have the probability of finding p electron, you have the probability of finding d electron, as well as you have the probability of finding f electron. If so many orbitals electron can be found in this small volume element, then obviously the value of 4 pi r square psi square r will also increase if r is increased. Because R is increasing as well as psi square R is also increasing, because you are getting electron from s orbital, p orbital, d orbital, f orbital as you are going away from the nucleus. If you are staying very close to the nucleus, you are getting only s orbital electron. Number is 2, p orbital 6, d orbital 10, f orbital 14. So obviously the volume element, if you are taking, in that s orbital might be also present, p orbital might be also present, d orbital might also be present, f orbital might also be present. That's why the graph with the value of r is increasing, and this happens in case of rp. So these are the three major graphs that you need to go through. Thank you.